Ksp Practice Questions. So in the previous video, we did look at the Ksp and the Qsp. Now we're going to be looking at some more advanced level questions for the Ksp in review of what we've been learning. Let's have a look at this first one. We have a volume of 0.3 liters or 300 milliliters, and that's pretty much all we're given. We're given the Ksp, right? So the Ksp we're given 1.48 times 10 to the negative 4, but what else can we derive from this MgOH2? Let's just first write it out the way it is, and from here, reversible reaction. What is it going to create? Okay, well, obviously we know that Mg is going to have a charge of +2, and we know that hydroxide has a charge of -1. In order to balance this out, we got to be putting a 2 over here, and now we are good. Whenever we're stuck, it's always good to be doing an ice table, so let's do an ice table here. And of course, initially we all just have 0 because we're not given anything in the question in terms of initial concentration. And we know that the change here, it has to be negative because this one's being used up. In terms of its variable, we'll just be putting as x because there's nothing else given really into the question. This is going to be obviously produced, so it's a positive. X is just because it's we don't have anything else in the question. We'll just put x as the variable in question, and then obviously this is going to just be 2x over here. We're going to add this and sum this all up for our ease, just bring this all down, and this is what we have. Now, we all always know that the Ksp is equal to the two products over here multiplied together. So of course our first product is our Mg2 plus, and our second product is our OH minus. Now, there is no coefficient in front of there. There's only a 1, so technically there's a 1 coefficient up there. There's a 2 coefficient up here, so we're putting it over there. If you have no idea why we're doing this, see the previous video. Link is in the description about Ksp. Now we're just going to be filling in what we have. Alright, so we know our Ksp, as written over here, is 1.48 times 10 to the negative 4. Okay, and then in terms of our Mg, it's just an x, so we'll just put x over here. And in terms of our OH, we have 2x, and do not forget the squared over there. So this is going to be the same value, 1.48 times 10 to the negative 4. This x will stay over here. Let's just expand this. So this is obviously 2 squared gives us 4. X squared just which is x squared. And then let's just bring this over up here. So this is going to still be our Ksp. Our x kind of stays the same. This one over here, sorry, the 4 times 1 over here just gives you 4, and then this x squared, and then this x exponent rule, right? This 2 exponent adds with the 1 exponent over here, so you get 4x to the 3, okay? So let's just kind of finish this all up right now. We have 1.48 times 10 to the negative 4 is equal to our 4x cubed. Just divide by 4 on both sides to ensure that we get x to the 3 is equal to whatever this is. What do you get? 3.7 times 10 to the negative 5. And then from there, we just cube root it. If you do it on the right side, you got to do it on the left side. What do you end up getting for your x? Getting 0.033322218. Okay, and of course, this is all in moles per liter. Are we done? No, the question is asking to determine the mass of this, right, of this MgOH2 to make 300 mils. Remember, this is all in concentration, and whenever we deal with concentration, it's always in molarity, right, moles per liter. So I'll just bring this up here just to make it a little bit more clear. Okay, moles per liter just means 1 liter, right? We don't want 1 liter. We want 0.3 liters. Okay, so obviously a lot less. So how are we going to incorporate this 0.3 liters with this calculation over here? Well, we know our C is equal to N over V formula. We know that this here is our concentration, which is this one, right? We know that our volume here, it's instead of 1 liter, it needs to be 0.3 liters, okay? And then for moles, that's where we're going to eventually find out, right? So if this here is our concentration, and then our moles is we don't know, and in terms of our volume, it needs to be 0.3 liters. What are we going to end up getting? Well, of course, in this case, we have to isolate for N. We have to multiply this by 0.3 liters. If you do it on the right side so that these cancels out, you got to do it on the left side. And then, of course, this cancels out with this, so then you just multiply these two. What do you end up getting for your N value? Getting 9.9966. times 10 to the negative 3 moles. Now, moles is not what we actually want. We're trying to find it in mass, so mass is obviously going to be in grams. So I'm just going to get this value over here. And then of course I have to multiply by something on the bottom over here diagonally, which has to be in moles so that they can cancel out. What can I put on the top? I can put it in on the I can put grams on the top. Now I have grams per mole, which is pretty much molar mass that we can find on our periodic table. What is the molar mass of Mg and 2 oxygens and 2 hydrogens? What do you get over there? At 58.3197. This cancels out, this cancels out. What do you end up getting left over for your G? Getting a value of 0.58300 grams. This is your answer. So we can see we have a Ksp value of 9 times 10 to the negative 6. Calculate the molar solubility of that, okay? But they also tell us that there is 0.05 moles per liter, okay, molarity solution of this, okay? So you're probably thinking, why is there sodium, right, with this chromate as well as this silver from this chromate? Well, if you're kind of confused over here, it's okay. Let's just start with what we know, okay? We know that we're going to be dealing with a Ksp of this compound, so we obviously have to break up this compound, not this compound over here. So let's just deal with this one that we need to kind of focus on, our silver chromate. So let's put this in Ag2CrO4. And then we're just going to break it up so then our silver is just kind of on its own. Obviously it has a charge of 1, as you can see over here. And then our chromate is going to be 2 minus. In order to balance this out, we'll just be putting a 2 over there. And then now we are good. Okay, so let's just continue to do with our ice table like we always do to make sure that everything is as succinct as possible. Let's kind of look at where this Na2CrO4 is involved in this. Well, obviously the common denominator here is this, right? Which is probably this one over here. So this CrO4, right, came from this Na2CrO4. Well, then where did this Ag come from? Well, we don't know. It's not written in the question, but this Ag probably came from something else, right? Like Ag maybe Cl or Ag something, like another anion that we just don't know about, but it really doesn't matter. All we know then that is important is that we have these two being produced, being yielded over here. Now, nothing else is written in the question about our initials, so all of these are just going to be 0. Of course, this is being consumed, so we have a negative x. And of course, this one here are being produced, so we have a positive. Obviously, all of these are going to be x. There's nothing else given in the question, so we just have to be putting an x as a default. But there's a 2 mole over here, so we're putting a 2 over there. And let's just add all of this up over here. So now we can finish off with our Ksp formula. Okay, so Ksp is equal to obviously our products. And what are going to be the products over here? Well, we have Ag is one product, and we have chromate as our other product in terms of the coefficients. This 2 needs to become a power, and then this 1 over here also becomes the power, but that's just 1, so we can just leave that out. And now we'll just fill in the details. All right, so we know our Ksp as written is 9 times 10 to the negative 6. In terms of our Ag, we know that it's a 2x, so we'll just be putting 2x. That's going to be squared. Our CrO4 is just an x, so that becomes put over there, and there's this exponent of 1. However, before we continue to bring this up over here, we need to kind of identify another thing that we know in the question. The question does say that we have 0.05 moles per liter of this, right? So we actually have to add this number into here, our 0.05 molarity, or moles per liter. Okay, and you're probably wondering why, right? That is to do with our Na2CrO4, not our CrO4. This X should be for the CrO4, right? What's going on? Okay, the reason why this still applies as our CrO4, despite it being from this compound Na2CrO4, is because we are obviously adding this, our Ksp relating to this compound, into the solution of Na2CrO4. And this here is the anion that is involved within the solution. We are adding this Ag2CrO4 in the solution. So CrO4 here, our chromate, must be the anion in this case. So if our 0.05 moles per liter of solution is regarding this compound, it also has to solely identify for our CrO4 only, because, like I said, CrO4 is a common denominator for both, right? For both the one that is in the solution as well as what is being added into the solution. Hence why it remains consistent, and we have to now add this within our CrO4. Now that I've done that, let's just expand this out. So obviously this just becomes 4x squared multiplied by our 0.05. Let's just continue to multiply these together. 4 times 0.05 gives you 0.2x squared, and let's just continue to keep going. Divide this by 0.2, divide this by 0.2, these cancels out, so you get x squared is equal to 4.5 times 10 to the negative 5. We're just gonna square root this, what you end up getting for your x, 6.71 times 10 to the negative 3. So this here is going to be our concentration. Now the question does ask what is the molar solubility, and of course molar solubility has to be in moles, right, per liter, and that's what this is, right? X is always going to be in moles per liter. We're always dealing with this always in a moles per liter concentration ice table. So this here would suffice. This here is your answer. They give us our Ksp as 1.7 times 10 to the negative 12. We don't know what the volume is. We're trying to find that. But in terms of its moles that they give us, it is 0.010. Okay, and the 0.010 is of AgCl, okay, of the whole compound. So let's just write this here. And again, this is for the AgCl. Okay, the moles for that one. So of course, whenever we have a compound like this, I want to break it up into its constituent anions and cations. So there we have it. So I'm just going to be putting a little ice table on the side to make sure that we have everything down packed. Alright, so obviously our initial concentrations, they're not given in the question, so they're all just going to be 0. They're being used up over here, so it's going to be a negative. And it has to be an x variable because we don't know what else is written in the question. Okay, what else is being used up, so we just have to be putting x. What is being produced, we don't know yet, so we just be putting a plus x and also a plus x over here. There's no coefficient in front, so we just leave it as just x's. Let's continue to bring it down. Okay, so now what do we do? Well, we know our Ksp is going to equal our two products multiplied to each other. Now, if you're probably thinking, well, how about this 0.010 moles, right? Isn't this 0.010 moles of AgCl, isn't that this one right over here? So technically, if this one is 0.010, shouldn't this one and this one also be 0.010? So shouldn't this be 0.010 and shouldn't this be 0.010, and then that's going to be our product? No, that's not how it works, because, well, first of all, this is just for our AgCl, and even though x value here should be the same as this x value over here, remember, for the Ksp, it only really matters what the product is going to be. So it really doesn't matter that 0.010 moles is of AgCl. AgCl here is our reactant. We don't care, okay? We only care about the products. So we have to just continue to go throughout this process as we just use with the x's. We cannot assume that this is 0.010, and we cannot assume that this is 0.010. So let's just continue to go throughout this process, just like we've been doing with our variables of x's. So our Ksp here is going to be 1.7 times 10 to the negative 12, and this is obviously going to be x squared, so we're just going to square root that, what you end up getting for x now. You get 1.303 times 10 to the negative 6. Now, what do we do? Well, and our Ksp, right, is dealing with AgCl, and what we also got was that this product and this product, which is pretty much just Ag and Cl concentrations, if they multiply together, they're technically the Ksp. So that's kind of circularly reasoned right now, which means that this value here is for our AgCl. Again, in case you're confused, just let me explain this one more time. Our Ksp, right, is going to be 1.7 times 10 to the negative 12. So AgCl's Ksp, again belonging to the AgCl, is this number, but this number is also equaling our two products. What are the two products? Ag and Cl, right? This one and this one. So of course, if you put it all together, technically these two products multiplied together is equaling this value over there. And if these two products are giving us this number, that means this number also belongs to the AgCl. So this concentration here is for the AgCl. Now, in terms of the moles, they're actually given to us in the question in its entirety, right, of the whole compound, it's 0.010. In terms of the volume, we have no idea. That's exactly what we're trying to find. And this is actually perfect for us because now we can just use a easy little formula of C is equal to N over V. And 010 moles times liter is equal to our 1.303 times 10 to the negative X. Okay, this is in moles times our volume. Okay, so now we're just going to divide this by our 1.303 times 10 to the negative 6 moles. If you do it on the right side, you got to do it on the left side over here. How do I finish off this question? Obviously, these cancels out with these, so then we end up getting our volume of, again, this cancels out with that, this cancels out with that, 7,674.5, no, we can just be putting 0.60 is enough. Again, this is obviously in liters. This here is your answer. These are the two green questions of the day. Obviously, this is the first one. This is the second one. Please pause the video, try this yourself on your own, and I'll be giving you the answers shortly. This is the answer to the first question. This is the answer to the second question. I will slowly scroll down.